Serverless computing. In the dynamic realm of cloud computing, the concept of serverless computing has emerged as a transformative force, redefining how applications are developed, deployed, and scaled. Contrary to its name, serverless doesn't mean the absence of servers but rather a paradigm shift in which developers are liberated from managing infrastructure. Let's explore the intricacies of serverless computing, covering its definition, types, services, benefits, and examples, and unwavering the magic of how it works. Definition of serverless computing. At its core, serverless computing is a cloud computing model that allows developers to focus on writing code without worrying about the underlying infrastructure. In a serverless architecture, the cloud provider automatically manages the execution, scaling, and maintenance of the servers, enabling developers to deploy code in the form of functions. These functions, also known as serverless functions of FaaS, function as service, are units of computation that execute in response to events without the need for explicit server provisioning. Types of serverless computing. Serverless computing comes in different flavors, and two prominent types are backend as a service. BaaS focuses on outsourcing the backend responsibilities of an application, such as databases, storage, and user authentication. Examples include Firebase and AWS Amplify. Function as a service, FaaS. FaaS is the more widely recognized type of serverless computing. It revolves around breaking down applications into discrete functions that are triggered by events. Popular FaaS providers include AWS Lambda, Azure Functions, and Google Cloud Functions. How serverless computing works. The magic of serverless computing lies in its ability to abstract away the complexities of infrastructure management. Here's a simplified overview of how serverless computing works. Event triggering. Serverless functions are triggered events. These events can include HTTP request, changes in data, such as updates to a database, scheduled intervals, or custom events generated by other services. Function execution. When an event occurs, the serverless platform instantiates the corresponding function. The function's code is executed in a stateless environment, allowing it to process the event. Automatic scaling. Serverless platforms automatically scale resources to handle the incoming workload. If the demand increases, additional instances of the function are created, and if the demand decreases, excess instances are terminated. Stateless execution. Serverless functions are designed to be stateless, meaning they do not retain information between executions. Any required state or data is typically stored in external services like databases or object storage. Pay-as-you-go billing. Users are billed based on the actual execution time and resources consumed by their functions. This pay-as-you-go model ensures cost efficiency, as users only pay for the computing resources used during function execution. Services offered by serverless computing. Key services in the serverless computing landscape include AWS Lambda, Amazon's FaaS offering. AWS Lambda allows developers to run code without provisioning or managing servers. It supports multiple languages and can be triggered by various AWS services or HTTPS requests. Azure Functions. Microsoft's FaaS service Azure Functions supports multiple programming languages and can be triggered by various events, including HTTPS request, databases changes, and timers. Google Cloud Functions. Google Cloud's FaaS enables developers to build and deploy functions that automatically scale in response to incoming traffic. It supports multiple languages and integrates seamlessly with other Google Cloud services. Benefits of serverless computing. Embracing serverless computing brings a myriad of advantages to the development operations processes. Cost efficiency. Serverless computing follows pay-as-you-go model, where users are billed based on the actual resources consumed. This eliminates the need for front infrastructure investments and ensures cost efficiency, especially for applications with variable workloads. Auto-scaling. Serverless platforms automatically scale resources based on demand. Functions are instantiated and run in response to events, and the platform takes care of scaling up or down to match the workload, providing optimal intervention. Reduced operational overhead. With serverless computing, developers offload operational tasks, such as server provisioning, maintenance, and scaling, to the cloud provider. This reduces the operational overhead, allowing teams to focus more on coding and less on infrastructure management. Faster time to market. Serverless architecture enables rapid development and deployment cycles. Developers can focus on writing code for specific functions, and the serverless platform takes care of the rest. This results in faster time to market for new features and applications. Scalability. Services functions automatically scale horizontally to handle varying workloads. Whether there's a surge in traffic or minimal activity, the serverless platform adjusts resources dynamically, ensuring optimal performance and responsiveness. Examples of serverless computing. Several organizations have successfully leveraged serverless computing to enhance their applications and workflows. Netflix uses serverless computing for various functions, including image processing and encoding. By leveraging AWS Lambda, Netflix achieves cost-effective scalability for these specific workloads. Airbnb employs serverless computing to enhance its data processing workflows. By using serverless functions, Airbnb handles tasks like data transformation and aggregation without the need to manage the underlying infrastructure. Slack utilizes serverless computing for certain features, such as message reactions and notifications. This allows Slack to handle these functions efficiently and scale automatically based on user activity. Serverless computing represents a paradigm shift in the world of cloud computing, offering a more streamlined and cost-effective approach to application development and deployment. By abstracting away infrastructure management and providing auto-scaling capabilities, serverless computing empowers developers to focus on building features and delivering value to end users. As organizations continue to embrace the serverless model, it is poised to play a pivotal role in shaping the future of cloud-native applications and accelerating innovations in the digital landscape.